তো তাহলে আজকে শুরু করছি হিউম্যান আই। এই চ্যাপ্টারটা আসে কারণে অপটিক্যাল ইনস্ট্রুমেন্টস তো এই চ্যাপ্টারটা 3টে সেগমেন্ট রয়েছে। ফার্স্ট হচ্ছে কিনা বেসিক কনস্ট্রাকশন অফ আই। হ্যাঁ, তো কনস্ট্রাকশন অফ আই আমরা শিখবো। নেক্সট হচ্ছে কিনা অপটিক্যাল ইনস্ট্রুমেন্ট, এটা হচ্ছে ফার্স্ট পার্ট। সেকেন্ড পার্ট হচ্ছে এখান থেকে বুঝবো যে কেমন করে অপটিক্যাল ইনস্ট্রুমেন্টের রিকোয়ারমেন্ট এলো। আর থার্ড হচ্ছে ডিফেক্টস, কি কি ধরনের আমাদের চোখের সমস্যা হয় রিগার্ডিং দা ফরমেশন অফ ইমেজ, তার উপর আমরা ডিসকাস করবো। তো প্রথম পার্ট যেটা আছে সেটা হচ্ছে কিনা কনস্ট্রাকশন অফ আই। তো আই এর ব্যাপারে কি বলা হয়েছে? সো আই ইজ নিয়ারলি এ স্ফেরিক্যাল শেপ জুয়েল, that is called the eyeball, whose diameter is about 1 inch. So diameter of this eyeball is around 1 inch. So I can take this diameter is around 2.5 centimeter. 1 inch means 2.5 centimeter. Front part of the eye, front portion is more sharply carved. যেই পোর্শনটাকে কিনা বলে কর্নিয়া। কর্নিয়া ইজ বেসিক্যালি দিস পার্ট ইজ দ্য কর্নিয়া অফ দ্য আই। এই কর্নিয়াটা কি করে? ইট উইল গিভ এ প্রোটেক্টিভ লেয়ার অফ আওয়ার আই, ওকে, সো দ্যাট দ্য ডাস্ট পার্টিকেল অর সামথিং লাইক দ্যাট ক্যান নট গো ইনসাইড আওয়ার আই, ভেতরে যাতে না ঢুকতে পারে। হ্যাঁ, কর্নিয়াতে এসে পড়লো সেটা ঠিক আছে, কিন্তু দ্যাট পার্টিকেল শুড নট গো ইনসাইড। সেই কারণে প্রোটেক্টিভ লেয়ার দেওয়া রয়েছে। দ্যাট লেয়ার ইজ বেসিক্যালি ট্রান্সপারেন্ট। So front portion is more sharply carved, so curvature is very high, and it is covered by a transparent protective membrane called the cornea. Why it is called transparent? Because transparent means now the light can go inside. আমি যখন লাইটটা বাইরে থেকে আসছে, so it can go inside. So by means of refraction. So transparent means refraction is allowed. So refraction of light is allowed, and because of which the light can go inside after the passing to the cornea. That's why cornea is a transparent. So this is the basic construction of the eye, where we are saying that the eye is a spherical shape geometry. So nearly spherical, roughly square ধরবো আমরা। And for the sphere, the diameter is around 2.5 cm. That is varying, person to person, human to human, এই নাম্বারটা ভ্যারি করবে, কিন্তু around আমরা ধরবো যে around 1 inch is the diameter. Now there are two important part of the eye apart from the cornea. So cornea is the basic white part. White part, front portion of the cornea is called the white part, basically transparent part. Now there are two important constructions. That one is the iris. Iris is the colored part. এই যে ব্লু কালারের যে পার্টটা রয়েছে, মাস্কুলার পার্ট যেটা রয়েছে, so that may be dependent on our gene. So that iris may be blue colored হতে পারে, বা ব্রাউন হতে পারে, বা ব্ল্যাক হতে পারে, depending on the nature of our gene. The iris have different color, but one of the important part of the iris is that iris is the muscular part. Okay, it is a muscular diaphragm-like structure, and inside which there is a pupil. Pupil means small hole. So this part is called the pupil. This is a small hole. This is the diameter of the pupil, and this diameter is called the aperture diameter. Aperture diameter. So no chance of light coming back to the outside, right? Because light will go inside our eye through this hole. The hole is called the pupil part. It appears to black. আমরা কালো দেখতে পাচ্ছি। So whenever the light will go inside, it will never come back. লাইটটা এরকম করে গেল, এটা ভেতরেই চলে গেল, বাইরে থেকে আসবে না। Why? Because inside is the lens part. And আমরা যদি ধরতাম যে there is a mirror, so on that mirror, if I allow the light to fall, so light will come back. ফেরত আসবে। So what I am observing that whenever the light goes inside our eye part, it will never come back. That means inside there must be some kind of lens. Why? Because the refraction. If the process is reflection inside our eye, then whatever the light energy that goes in, that should come out. এটা আসতে পারছে না, তার মানে আমি বলতে পারছি যে inside there is a lens part. Now regarding the lens or regarding the pupil, so আমরা বললাম যে এই যে ম্যাসকুলার পার্টটা রয়েছে, that part is our iris part. Okay, so iris will expand or contract, দুটোই করতে পারে depending on the amount of light. If I enter inside a low light condition, then what happens? The amount of energy of light that comes inside our eye is less. তাহলে এখন পিউপিলটা করবে কি? এক্সপ্যান্ড। সো দ্যাট ইজ অ্যাপারচার ডায়ামিটার, যেটাকে আমরা ডি বলেছিলাম, দ্যাট ডি ডায়ামিটার ক্যান বি ইনক্রিজ, so that more amount of light energy can go in. More amount of light energy can go in, so that the image that is informed, that is clear. If the amount of energy that is falling on our eye part is less, the image will be also hazier. The low light condition হবে কিনা more amount of energy আমাকে নিতে হবে, that means our iris will expand the pupil. So these are the iris part. So they will pull the pupil part in the outward, readily outward direction. So because of that, it will expand. Pupil part expand হবে না। And whenever we are entering inside the good light condition, where the energy of light is sufficiently high, so iris contract. তো ছোট হয়ে যাবে। Why? Because we don't allow more amount of energy to go inside. So pupil basically contracts or expands, and depending on that, it will allow the light to be controlled, amount of light to be controlled. Okay, but the amount of light is nothing but the intensity of it or intensity. So more the light coming in our eye, more amount of intensity. Intensity is directly related to energy. Yeah, intensity is directly related to energy. So more amount of intensity is more amount of energy of light is coming in. So our eye is not ready to use that. So eye is always using some less amount of energy. That means it should be controlled amount. আমরা যদি বলি যে অনেক বেশি পরিমাণে এনার্জি আমরা আয়ের মধ্যে ঢুকিয়ে দিয়েছি, লাইট এনার্জি, দ্যাট উইল এফেক্ট আওয়ার আই। তো আই অটোমেটিক্যালি ডাজ দিস প্রসেস। আমাকে করতে হচ্ছে না, অটোমেটিক্যালি দ্য আইস মাসলস আর পুলিং অর পুশিং, কন্ট্রাক্ট করছে বা এক্সপ্যান্ড করছে, ডিপেন্ডিং অন দ্যাট টু ভ্যারি দ্য অ্যাপারচার of the pupil. And that variation of the aperture is done to ensure that a sufficient amount of energy will go in, not more, not less, depending on the light condition. যখন বেশি লাইট রয়েছে আমরা করবো কন্ট্রাক্ট করবো, সো অ্যাপারচার উইল বি লেস, ছোট অ্যাপারচার হয়ে যাবে। when the low light condition, aperture will be more, so here the aperture is more, so more amount of energy will go in. So depending on the amount of energy আমরা কতটা দরকার to form the correct image, so iris will adjust itself to form the pupil. Pupilটাকে আমাকে ছোট বড় করতে। Now come to the eye. So eye has a lens. Eye has a lens. So lens is hard in the middle. So this portion of the eye is basically the lens. This is the lens part. Regarding the lens কি বলা হয়েছে, at the middle portion, এই portion is hard. এই portionটা hard রয়েছে, and outer part are soft. Outer edges are soft. Outer edges are soft means they are soft on the outer. মানে এই portion গুলোতে soft হয়। This part of the lens is soft. এবং লেন্সটা ছবি থেকে বোঝা যাচ্ছে this is a type of converging lens, or I can say convex type of lens. The curvature of the lens and hence the focal length can be altered by the ciliary muscles. Okay. So this lens is held between our eye using by a muscular structure. So these muscles are basically the ciliary muscles. These are called the ciliary muscle, ciliary body. So this will hold our lens. আমি আগেই বললাম যে এই পার্টটা সফট পার্ট রয়েছে। So the ciliary muscle can push this soft. So when it pushes the lens, the lens become bulger, মোটা হয়ে যাবে, and it may contract also. The ciliary muscles apply a force continuously on our eye lens so that the curvature can be varied. So that the curvature of the lens can be varied. Regarding the lens, when we learn the lens, we see that the focal length of a lens, mu is mu, and if I say it is the equiconvex lens, equiconvex means both the surface has same equal radius r and r. So for that আমরা define করেছিলাম যে 1 by f number is how much, that is equals to mu minus 1 is 2 by r. Okay, that is called the lens figure formula. So that means what you understand, that if I able to vary this r number, radius of curvature, now which is being done by applying the force on this. এই force যখন apply করলাম, I can vary the aperture. এই forceটা কে apply করছে, ciliary bodyটা. So that means I can vary the focal length. I can vary the focal length. So that means the curvature of the lens can be varied by applying the force on the lens, and force is applied on the softer part of the lens. This part of the lens is soft. So since soft part is much more affected by the applied force, so lens will be bended. So once you apply a force like this, the lens can have a bulge out করে যাবে. That is in that situation. So more the bulging means R number will be less on the lower side. Okay. In some situation, it may be possible that the ciliary muscles are pulling the lens. উপর দিকে টানছে. So once the ciliary muscles are pulling the lens in upward direction, then what happens? The lens becomes thinner. So whenever the lens becomes thinner, the R number will increase. Why? Because R is nothing but the radius of curvature. R is nothing but the radius of curvature. That means এই যে রেডিয়াসটা হয়েছে, radius is R prime. So R prime is nothing but This for circle. This circle. Okay. Earlier this circle was larger circle. So R was more. So যখন আমি ফোর্সটা দিলাম toward downward direction, that means R is increased. R is reduced. So R prime number is less than R. And whenever I am pulling the length in this direction, then it becomes thinner. So thinner become more larger circle. So now here R double prime, this number is more than R number. Okay. So that means by applying the force on the ciliary muscle, or by applying the force by the ciliary muscles on the soft part of the lens, the curvature can be altered. And since the curvature being altered, that means what we can ensure that the lens focal length is also changed. Okay. So that is the idea of the eyes. So whenever the image is being formed on the retina, always image has to be formed on the retina. That means retina is acting like a screen. Retina is acting like a screen. On that screen, I have to produce the image. So what is that retina part? Retina part is this part. This part is the retina. So on that retina, our image has to be formed. Since I am saying the retina is acting as a screen, and on that screen the image is being formed, so image must be virtual. So this convex lens is producing a virtual image on the screen itself, virtual image, as well as it is inverted. So there is an object. For that object, the image is being formed on the retina. The nature of the image formed on the retina or the screen that we say is basically the virtual and inverted. Well, whenever the light is coming from this object, whenever the light is coming from the object, so light got refracted using two different combinations. One is the cornea part. So this cornea, it is the protective membrane, will deflect the light, and then comes the lens. So both are acting for the converging of the ray. So it has been stated that most of the bending of the ray occurs at the cornea itself. So front part is the cornea. Maximum majority of the bending is taking place due to the cornea part. Why? Because it is the curvature part. And again, another type of bending is occurring in the lens part. Okay. So ultimately, the image has to be formed on the retina itself. Why? Because it is a converging type of lens. So all the rays must converge to a particular point. So once this image is formed, that image is formed, and it's called the virtual image and the inverted also. But this virtual image, which is inverted and also diminished in size, diminished in a small size. So now this image has to go toward brain. Okay, so through this nerve. So there are optical nerves connected with retina. So this optical nerve will send the signal to our brain, and brain will sense this image. Brain will sense the image. So whenever I see any object, I see what? Initially I see the virtual, inverted and diminished. Now this signal is transferred to our brain through optical nerve. So brain is analyzing this signal. Now whenever I am supplying a signal to this nerve, that signal has to transmit at a very high speed. What is that speed? The speed is more or less equal to the speed of light. So with the speed equal to c, that is c into 10 to the power 8 meter per second, this signal is going in our brain. Now inside the brain, there is a memory space where the images are being stored. Whatever the object that we are seeing, all the objects are recognized by myself. Why? Because these objects are previously seen. আগে আমরা দেখেছি। এমন যদি কোনো একটা অবজেক্টকে তোর চোখের সামনে আনি, which is not previously seen, so you cannot identify. Why? Because brain has no copy of that particular image. So brain has a storage device. Inside that, all the images are being stored. Okay. Now it is called the permanent memory. And there is another part of the brain which is called the volatile memory. So some part of the memory has to be erased every time. This is called the volatile part, where some image or some information has to be erased every time. Why? Because brain has a capacity. It cannot store a large amount of storage data. So for that, some amount of information you have to erase. Like, let us say, if I ask you that what you have eaten in 2 days before, what you have taken in dinner in 2 days before, you cannot see. Why? Because that information is not so much important for the brain to memorize or to remember. But if I ask you, what is the name of your friend in your class 4th level or 5th standard? you can remember. Why? Because brain has stored that particular data. Okay. But in the long process, after 10 years or 20 years or 50 years after that, if I ask you, name the friend of your classmate in belongs to your class 5 standard or class 6 standard, you cannot say. You may say that or you may not. Okay, it depends on the varies between person to person. Okay, so brain has that ability that what portion of the information they have to store and what portion have to not to be stored. So the portion which has to be erased after some time that goes inside the volatile, and this is the fixed memory that is there, the fixed part. So whenever I see any object, the optical nerve send the signal to our brain. Now brain will send this image or the information to this fixed information part, to the fixed part. Now after that the scanning process starts. So once the scanning matches with the information that is stored inside the brain, then the brain signal another feedback signal. This is the feedback signal. Feedback means what? Feedback gives basically the information is correct or not. So whenever I see let us say I see a sign, a signboard is there. Let us say I see a signboard. So brain will signify, brain will analyze that this is a signboard and this should be the image of that signboard, and you should see in a basically erect, not in inverted way. And you should see the correct image of this by applying the concept that you should enlarge. So all those information are processed inside our brain, and they say brain send this feedback signal to our eye so that after that I can view it properly. Okay. So entire process takes some amount of time. Entire process takes some amount of time. Initially I see the object. Once I see the object, the image is being formed after that. Now the image that has been produced on the retina itself that sends a signal through this optical nerve to our brain part. Okay. And then brain recognizes it, and ultimately scanning is going on. After the successful scanning, brain sends a feedback signal. So entire process takes some amount of time. But since this occurring at a speed of light, I cannot see that particular time. Okay. It is occurring at a very fast. Whenever I see the object, I recognize what is that. Why? Because brain is scanning the entire process so fast because the signal is going at the speed of light. So that means it is very, very fast process. Okay. So with the age, this scanning process becomes quicker. Right now, suppose you are in the age of 15 or 14. So at that particular age, your scanning process fast. But as you grow up, then the scanning process becomes slower. So ultimately, one point will come when the scanning process becomes so weak that you cannot recognize anything. That may be another kind of disease. Okay. So there may be another kind of disease where brain is not recognizing any image. Any image, whatever I have seen, I cannot recognize. Why? Because brain is doing the same process. Scanning process is there. But with the age, it may be possible that brain cannot store that sufficient information. And in that process, let us say information is there, but brain cannot send the feedback signal. So if the brain is not able to send the feedback signal, then I cannot analyze the whatever I have seen. Okay, that is another type of error, or another I should say that this is the entire process that goes in. And also along with that, you have to identify the color part. Along with that, you have to identify the color part. So whenever I am sending the signal, the sending signal has to be goes through these two types of cells, rods and cone cells. Okay. Mostly these cone cells are recognized for the color part. So what is the color of the object that has been identified these cone cells, and regarding the size or nature of the image, what is that? Let us say I see an elephant. So I have to identify that is a kind of elephant. That signal is passed through this rod type of cell. So these are the two different cells, and number of cells are millions of cells. Okay. About 1 million optical nerve fibers are there corresponding to the 125 million receptors. So one will receive the signal and then coming to the feedback signal. Okay. The entire process is going on. Every time this process is going on. Whenever I see the object, our rod cells and cone cells are active. Since the cone cells mainly consider the color of the object, so if in a low light condition, let us say in the night I cannot see the color properly. Why? Because it is a low light condition. So that means the cone cells are not active in that situation. So mostly in the night condition, the cone cells are not active. But in daylight condition, rod cells are active as well as the cone cells are active. The cones are mostly active in the daylight condition where the sufficient amount of light is there. Why? Because under the sufficient condition of light, sufficient amount of light is there, then only I can identify what is the color of the object. In a low light condition, if I see the object, then the color may not be identified properly. আমি একটা কালারকে দেখলাম and I say it is a blue color. It may not be a blue color. Why? Because the cone cells are not active at that point because of the low light condition. But there are certain animals or mammals basically. So for that, both our rod and cone cells are equally active in day and night condition. And it might be possible that they are active in the night condition. Okay. So they may be different for different part. But for human being, the cones are not so much active in case of night condition. Now come to the eye part. So eye is this is the lens part. This is the lens part. And the lens is surrounded by two types of liquid. One part of the lens, front part of the lens is covered by a liquid known as the aqueous fluid. Okay. And back part of the eye lens is covered by another liquid that is the vitreous. Why these liquids are there? So these liquids are basically allowing the lens not to be dried. Okay. So our eye lens should not be dried. Why? Because these two liquids are there which continuously supply the some amount of wetness to this lens part. So under that wetness condition only the lens will act. If by any means the aqueous humor part is damaged, then your lens will not work properly. That means you cannot see the image. Or the vitreous humor part is damaged, then also you cannot see. Okay. So both are the two important components of our lens. So on both sides of the lens, there are two medium basically. These are the two medium, and mostly the refractive index are both these mediums are almost same. And the value is around 1.396 in roughly I have said is as 1.4. 1.4. And regarding the lens part, so this is the mu for the medium, surrounding medium. And the lens has some value of mu and that is more than 1. Okay. So mu for lens medium is taken to be around 1.5 to 1.6. This is the normal range of mu for the lens for the eye. Okay, this is the normal. Okay. It may be slightly vary also, but it is this number. But you have to be very sure that mu L number is always greater than mu S number. What is mu S? Mu S is the surrounding medium. Okay. The surrounding medium refractive index, let us say I am saying mu S, and the lens medium is let us say mu L. So condition is that mu L is always greater than mu S. Every time mu L should be greater than mu S. Why? Because under that condition only this lens will act as a converging. Because our eye lens should act as a converging. There is a convex type of lens. Why? Because then only the light ray can be converged. If the ray becomes diverging, then the image is not formed. Okay. So in order to make a converging lens, so the mu L number, that the lens medium, must have the value which is more than the mu S. Okay. Now let us do one particular calculation to calculate the focal length of this lens, assuming that the radius of curvature are more or less given to you, almost given to you. So for that, what we use that 1 by f should be equals to mu L by mu x minus 1 into 2 by r. This is the focal length. Okay, this is the focal length. Now, once I select a lens, so for our eye, mu L number, mu S number is almost constant. So what is that number? If I write the mu L is about 1.5 divided by 1.4 minus 1 into 2 by r. This is the number. So 1.5 minus 1.4 is 0.1. So 0.2 divided by 1.4 into 1 by r. So roughly what you can say 1 by 7r. Now, so A becomes almost 7r. What is r? R is the radius of curvature. That r is not the diameter of the eyeball. So what we are saying is the diameter of the eyeball is around 2.5 cm. That is not our r. 2.5 cm, that is the diameter of the eyeball. So radius of curvature is somewhat different. So roughly thumb rule is focal length of the lens is around 7 times of radius of curvature. If I am assuming that the lens is equiconvex. So for that I can use the 7r value. Okay. But what is the advantage of this type of lens is that now the ciliary muscles are there. Ciliary muscles are there. These ciliary muscles can push the lens or they can pull the lens. So whenever they are pushing the length, that means now the R is reduced. If the R is reduced, then the focal length is also reduced. If they are pulling the lens, that means R is increased. And in that situation, F is also increased. That means I can vary the focal. I can vary the focal length. So focal length of our eye lens can be varied. But whatever be the lens that we are thinking about, artificial lenses are there. So those lenses, focal length cannot be adjusted. Why? Because once they have been constructed, they have given a certain value of R. Radius of curvature is no corresponding to that R number. I cannot change that. Okay. So that R number is fixed. So since the R number is fixed, but I can ensure that for those lenses, those artificial lenses, the focal length is constant. That is the beauty of our eye. I can vary the focal. And why it is essential? Why it is essential? Let us say there is an object, and this is the lens part. This is the lens part. Now, whenever the light is coming from a distant object or from a near object, the intention of this, our objective is to get that converged to a point which is basically that should be on the retina itself. Okay. So whenever the object is there, every time I am trying to ensure that the image is being found on the retina itself. So that means this distance, can I take that V is around 2.5 centimeter almost. Every time the V image position is 2.5. An object may be near or far. So the U number is varied. U is varied. Whenever I am seeing any object, so object, let us say this is the object O1. So let us say O1 is at a position of 50 centimeter from our eye. Okay. In some situation, O2 is there, which is let us say 100 centimeter from our eye. So that means for defined object, that defined object distance are there. Now if I apply the lens formula, so what you can write that 1 by V minus 1 by E equals to 1 by A. Now that I want to calculate the V number. Let us say V is always fixed. So since V is always fixed, so can I write 1 by V equals to 1 by U plus 1 by A? Or what you can say V equals to U by U plus A. Okay. Now in order to get the V number to be constant, I want to get the V number to be constant. If I vary the U, so initially let us say the U is 50 centimeters. Corresponding to that, I use one value of F and I got the value of V. Now, in the second situation, now let us say I got the value of U as 100 centimeters. For that also, I want to get the same value of V. That means that is only possible if I vary the F number. Okay. So, in order to make V to be constant, F should be varied. F should vary. Okay. So, that means the cornea, lens and fluid. So this is the cornea part, first part the cornea, then lens and the fluid medium is. Okay. So this cornea lens fluid system is equivalent to a single converging lens. Okay. And that lens has a focal length, we have already calculated that approximately equals to 7 times R. 7 times R. And that number has to vary so that the image is always formed on the retina. Okay, if I am not able to do that, then the image will not form on the retina itself. So our eye lens is so much sophisticated, so much advanced that I can vary this eye lens focal. Okay, that is not achieved for any other lens. Whatever be the lens, I think of, for those lenses you cannot vary this focal. Focal length vary করাতে পারবো. Why? Because now the R number can be changed. And it has to be changed so that I can every time ensure that image is being formed on our retina. So in order to produce the image on the retina itself, every time our eye lens has to vary its focal length. And this process is known as the accommodation. The process of adjustment of the focal length is known as the accommodation. So our eye will automatically do this accommodation. Now there are two extreme situations. What is that? In one way, let us say the object is very far away from your eye. So for this situation, I am saying it is almost tending to infinity. So from infinite distance, whenever I am saying the light is coming, so light are almost parallel to the principal axis. Okay. So light are almost parallel to the principal axis and they are hitting our lens by getting the first reflection from the cornea. So this is the first reflection point from the cornea, then it enters inside the lens and finally the rays are being converged to this point. Okay, rays are being converged to this point. Okay, So if the lens is not there, if the length is not there, then the ray will passes like this. Because of the lens, there is a deviation in the path, and that deviation is the delta. Okay. So I want to calculate how much delta is. How much delta is. So how much deviation is essential whenever the object is placed far away from this eye lens. So let us say this is the lens part, converging lens part, and I put a object over here. This is the object part, and rays falling on the lens like this way, and after convergence, let us say this is the portion, this is the point where the image is formed. Okay. So for this diagram, can I say if the lens is not there, then the ray will go in this direction. So this is the direction of the delta. So I want to calculate this delta. Okay. Let us say this angle is alpha, this angle is beta. Okay. Let us say this angle is alpha and this angle is beta. So object distance is basically in, this number is u number. Similarly, this number is the v number, image distance. Okay. And let us say this height where the ray will hit is, let us say, h. Okay. So h is the point from the optical center where the light is being reflected. Okay. So for this triangle, can I write entire triangle? Let us say this triangle, delta is the exterior angle and alpha and beta are the two interior angles. So delta should be equal to alpha plus beta. Okay. Sum of opposite to interior is nothing but the exterior angle. So delta is the exterior angle for the triangle. So delta is equals to alpha plus beta. Now since I am discussing about the eye lens, and this lens is very small in dimension. They are not large. Why? Because the entire dimension of this lens is 2.5 cm. Diameter is 2.5 cm. So within that the lens is there. Okay, within that the lens is there. So the lens dimension is also very small. Okay, lens dimension is also very small, around 1 centimeter. I can say that this height of this lens is around 1 centimeter. Roughly, I can take it as 1 centimeter. So that is very small. Very small. So since lens has a very small dimension, I can say that whatever be the angle alpha, beta, and deltas are there, these angles are also very small. So these angles are small. Okay, these angles are small angles. And whenever the angles are small, then this alpha can approximately be written as tan of alpha. Similarly, beta can also be written as approximately tan of beta. Why? Because these approximations can only be done when the angles are very small. If the angles are large, then you cannot do that. And mind it that whenever I am doing this calculation, that is alpha and beta should be in radian, not in degree. Okay. Now from this triangle, what you can write? Tan alpha equals to h by u and tan beta equals to h by v. Now according to the sign convention, we know that u should be put to the negative sign, v is the positive sign. So if after rearranging, so what I am getting that h into 1 by v minus 1 by u, and 1 by v minus 1 by u nothing but h by a. Okay. So what we got basically delta equals to h by a. So that is the deviation that we are looking for, h by a. H by a. So whenever the light is coming from a very far distance, for a far object, we can ensure that the rays are parallel to the pencil. That is true. And in that situation, whenever the rays are parallel to the pencil axis, the little value of refraction is being needed. It means the delta number should be on the lower side. If delta number is on the lower side, that means what you can say that f number should be on the higher side. Why? Because delta equals to h by a. So delta is on the lower side means f should be on the higher side. So if higher side means we know that a focal length of eye lens is around 7 times r. This is the number that we have discussed. So if I want to get f is on the higher side, that means r should be on the higher side. It means the r should be on the higher side. Radius of curvature of the lens should be on the higher side. That means lens must be thinner. Lens must be thinner. Why? The lens has to become shaped like this. So whenever the lens becomes thin, the radius of curvature is increased. That means the ciliary muscles are in relaxed condition. Whenever they are in working condition, that means they have to apply a force on the lens. Now, less amount of force is required by the ciliary muscles on this lens. So relaxed condition means the power of the lens is less. Power of the lens is less. So regarding the power of the lens, what we know that power of the lens is 1 upon a. Okay, power of the lens is 1 upon a. Now since f is on the higher side, So can I say this implies that the power of lens is on the lower side? Okay, that's why it is called the relaxed. That's why it is called the relaxed. So whenever I am seeing the object which is far away from our eye, that means the object I can say is a far object. That means it is called mostly you say mathematically I am saying that U is tending to infinity. Whenever U is tending to infinity, that means it is a object from where I am getting the parallel kind of rays. And whenever the rays are parallel, the refraction needed is very small. Refraction needed is very small. Why? Because the bending is less. Bending of ray, initially the light is coming in this direction. Initially the light is coming in this direction. So after the reflection, light should bend to this red direction. Here, in this direction of bending. So what is the amount of bending? That is called the delta. So delta number is on the lower side. And we have calculated the delta as h by a. Now since delta is on the lower side, so h should be on the higher side. H should be on the higher side because h number is more or less constant. The point where the light ray are reflected, that h number is not varying so much. Okay. Why? Because the dimension of the lens is 1 centimeter. So for that h is very less also. So only when the reflection is less, that is delta is on the lower side, that can be ensured that the focal length of the lens on the higher side. Now focal length, we have said that focal length is equal to 7 times of r, and I want to get a high value of focal length. That means the radius of curvature should be on the higher side. That means length must be thick. Length must be thin. So whenever I am trying to make a length which is thinner in nature, that means ciliary muscles are not working on the lens. That means power of lens is less. So this is the condition whenever I am seeing a object which is far away from our eye path. Okay. Now come to the situation where the object is moving closer to our eye. Let us say now the object is over here. Now whenever the object is at a certain some distance away from this, now the light rays are coming from the object in this direction. If the length is not there, so then it will go in this direction. And because the presence of the length, it goes in this direction. So now this is the delta number. Okay. So delta from this diagram quite easier to see that delta becomes on the higher side. So near object means the more the divergence. So much refraction needed. That means delta should be on the higher side. Delta should be on the higher side. And delta equals to h by 8. So that means h should be on the lower side. That is h number should be on the lower side. And we know that h is equal to 7 times r. So that means h lower side means r should be on lower side. That is r on the lower side. That is radius of curvature has to be lowered. So that radius of curvature can be lowered by putting more amount of force on the muscle, on the eye itself. Now what happens? The ciliary muscles are putting more effort. So here they are giving more amount of force. So because of this force, the lens become bulge. So whenever the lens are bulging, that means now the radius of curvature of the lens is increased. So that I can ensure that the focal length of the lens is reduced. And in that situation, if I want to calculate the power of this lens, the power of this lens is equals to 1 by focal length. Now focal length is reduced, that is power of the lens should be increased. So more power means more amount of force is required by the ciliary muscles to bulge. Okay. So that means lens become more spherical, and under that condition, ciliary muscles are contract. That means they are in stress condition. So they call stress type. So whenever you try to see an object which is very close to your eye, there is more stress on your eye. More stress on your eye. Why? Because ciliary muscles are putting much more effort to make the lens bulge. Okay. Now, if you increase it further, let us say at point 2, the ciliary muscles are doing some kind of force. So the lens becomes bulging. So if you want to so let us say now the object is over here, O prime. So now can I see that more amount of bulging is essential? Why? Because now the rays has to be diverted like this. Now rays has to be diverted like this way. So it means the delta becomes further increased. Okay. If the object moves closer to our eye, then the delta becomes increased. Whenever I shift the object, if I shift the object in this direction, the object is become closer to our eye. So in that situation, delta becomes more. Delta is increased. Now if delta is further increased, then what happens? I want to get that R number should be increased further. Okay. So there is a certain limit beyond which the ciliary muscles cannot push your legs. Okay. So whenever I am trying to increase the radius of curvature of the lens, that means the ciliary muscles are applying a force on the lens itself, and that force has a certain limitation. So muscles cannot be strained beyond a limit. That is the particular limit up to which our ciliary muscles can apply a force. Beyond that, it cannot apply. Let us say the limit is being reached. Limit is being reached that the ciliary muscles cannot apply more than that particular force, so that lens cannot be bulges more. And in that situation, the focal length is not adjusted properly. And that means if I put the object close to our eye, then the image will not be formed on the retina itself. Okay, because the focal length is not adjusted such that the image is being formed on the retina. So what we can conclude finally that in that situation, when the object is the O prime location, let us say the image is being onwards to this point, is the I prime. Now since I prime is not formed on the retina itself, now this image cannot be viewed. No, this image cannot be viewed. So I can view only those images which are being formed on the retina itself. So I prime cannot be viewed. Okay. So muscles cannot be strained beyond the limit, and because of that only I cannot view whenever the object is moving closer to our eye. There is a certain limitation. Okay. So if the object is brought too close to the eye, the focal length cannot be adjusted to form the image on the retina. Okay. So now in that situation, if the object is over here, then the image is being formed, let us say, at this position. Okay, image is, so this I prime is not formed on the retina itself, and that means this image cannot be viewed by our eye. Okay. So the nearest point which image can be focused on the retina is called the near. So there is a particular point position of the object where I should place the object such that now the image is being formed at this radius. Okay. So that distance from our eye is called the near point distance, written by the capital D. So capital D is the distance that is taken to be the 25 centimeter, beyond which if I put, let us say I put the object at a distance of 40 centimeter, then the image is being formed. No issue. Okay. If I put a object which is at a distance of, let us say over here, which is at a distance of 10 centimeter from 10 centimeter. So now the image is being not formed on the plate. Image is being formed. I cannot say the image is not formed. Image is being formed, but since the image is not formed on the retina, I cannot see. Okay. So the nearest point where an image can be focused on the retina is called the near point. Okay. So for a normal human being, this number is 25 centimeter. This number is 25 centimeter. But for the persons of lower age, the number can go up to 7 to 8 centimeter. That means that boy can see the image whenever can see the object whenever the object is much more closer than 25 centimeter. Okay. Why? Because for that person, now the lenses are not so much hard. So whenever we are putting the lens to be ciliary muscles to work, so now the ciliary muscle can apply large amount of force so that more bulging can be taken. Okay. So that's why the near point can vary, but the average value is around 25 centimeter. Average value is 20 centimeter. And that distance up to which we can see the object clearly is known as the least distance for clear vision or least distance of distinction. And that number is taken to be the near point distance, that is basically the capital D symbol, and we use that number as 25 centimeters. So generally this is capital D. And what is the far point similarly? So far point is basically for the human eyes around infinity. Okay. And near point is 25 centimeter. So every time whenever the near point is being asked, I should mark this at 25 centimeter and far point is infinite. That means if the object is a very large distance, then also I can see the image. Okay, see the image. So that means there are two situations. One situation is that object is closer to our eye. In that situation, the eye is in the stressed condition, and whenever the object is marked much more away, this is a far distance away, his eye is known as the relaxed state. This is known as the relaxed state. So these are the two extreme situations. Either the object is placed at here the object is placed at far point. Here the object is at far point. So whenever the object is at far point, then our eye is in relaxed state because ciliary muscles are not doing so much effort, not giving so much effort because lens are thinner. Now whenever we are bringing the object closer to our eye, then it becomes stressed condition. So this point is maximum stress occur at the near point. This is called the near point. Uh, At near point, if I place the object at near point, then the maximum stress condition is occur. So that's why it's called stress tie condition. So between these two, near point and far point, if I place the object, then I is something stressed, something unstressed. I cannot say that I cannot say that I is purely stress condition. Why? Because purely stress condition means the object should be placed at the near point situation. Okay. Now is that I ensure that the object has to be form an image on the earth. Now, in order to see the image clearly, there are two requirements. One requirement in order to see the object. In order to see the object, there are two requirements. One requirement is that the object has to be placed beyond this 25. Okay. So if I place the object over here, then I cannot see it. I cannot see. Why? Because this is the minimum, this maximum minimum distance up to which you can see. Beyond that I cannot see. So if the object is more less than 25 centimeter, placed at less than 25 centimeter, then that cannot be viewed. Okay. You cannot view it at all. Now, another important point is that the size of the image found on the retina. Now, depending on the position of the object, so let us say this is the AB object that is positioned, and the image of the AB object on the retina is A prime B. So this is the image of the object. So image of the object on our retina is A prime B prime. This is the image. Okay. Now, depending on the size of the image produced on our eye, that nature or that can be so. This is the image, you know it, and we by default you know that this image is diminished. It is diminished. Now, if it is diminished so much, then it cannot be extended or we cannot enlarge. So, one way of increasing the size of the image is that I want to increase the angle. Let us say this angle is important. Place angle is theta. So, object making an angle theta with our eye. Okay. If I make it closer to our eye, then the theta angle is increased. In that situation, in the second situation, theta angle is increased. Let us say in the second situation, when we put the object closer to our eye, then the theta becomes, let us say, alpha. So alpha is greater than theta. Now, since alpha is greater than theta, now in that situation, this is the formation of the image. This is the image part. Okay. So image length A prime B prime that was there initially when the angle is theta, now it is increased. Okay. So image length can be increased by this increase in angle. Okay. Increase in angle. Let us say you are viewing a object which is very, very far distant away from you. Let us say you are seeing a star or moon like that. So the star or moon is making an angle, let us say alpha in your eye. So that alpha is known as the visual angle. This alpha is known as the visual angle. So by any means, let us say you make a virtual object, a virtual image of this object which is somewhat closer to your eye. Okay. Virtual object somewhat closer to your eye. Now this object is making an angle. Can I say beta? So whenever this is the image, virtual image of the object, this is the object. By some means, you make an image of this object. Now this object becomes closer to your eye. If the object is closer to your eye, then the beta angle is more. Now if the beta angle is more, the image size will also increase. That means I can view this object more clearly. So let us say you are observing a very long distance star. So long distance star appears to be very tiny particle. Why? Because they are far, far away from ourselves. That means the angle alpha formed on our eye is very less. That means I cannot see it properly. A tiny dot is inside. But by any means, by some instrument, if I am able to make an image of that, and if I am able to make the image in such a way so that it becomes closer to our eye, then the beta angle is increased. Now, since beta angle is increased, now I can ensure that the star appears to be large in size for me. Okay, which is almost negligible dimension whenever I am seeing without any instrument. And with the instrument, if I see, then the image size being increased. Image size being increased. Not only that, the angle that is making in our eye, that is also increased. Okay. So size of the image on the retina is roughly proportional to this angle. Okay. So this angle, let us say the theta angle is being formed corresponding to that image size is, let us say, IU. Okay. If the alpha angle is being formed, let us say image size is I prime. Okay. So theta is proportional to I. Similarly, alpha is proportional to I prime. Okay. So more the angle, more is the image size. And more is the image size, means better is the view. But there is a limitation also. Because for this blue colored object, we cannot see it. Why? Because now this blue colored object is placed at a distance of, let us say, 15 centimeter. So if I place the object at 15 centimeter, then we cannot see whether any kind of instrument is being used or not. Okay. So that means in order to view it properly, so not only you have to ensure that the object is placed above the or more the distance which is 25 centimeter or the angle to be. Okay. So this is the idea of the visual angle. So whenever you are bringing the object closer, the angle will be. So it may be possible that you are not able to bring the object. So you cannot bring the star closer to you. So let us say this is a star. You cannot bring the star closer to, but with the instrument you can form an image of that, and that image may be formed somewhat closer to you, and that image is making an angle more angle at your eye. That is now the object size to be seen by ourselves is increased. Okay. So whenever I am saying, let us say this is the or R. This is also R. So around R, the moon is orbiting in an elliptical path, not in a circle. So let us say this is the moon position. So whenever the moon is farthest distance from the R, then it is called the apogee location. This is called the apogee location. Whenever the moon comes to closest to the R, then it is the perigee location. So these are the two locations where moon comes closer to our Earth or moon comes largest distance away from the Earth. The person who is sitting over here on our Earth, he sees this moon at an angle, let us say alpha. Okay. The person who is sitting on the other side of the Earth, here, he sees the moon at an angle, let us say beta. So since the distance is more for the apogee location, can I say beta is less than alpha? Yeah, beta is less than alpha. So that there is no change in the size of the moon. The actual size of the moon is same. But the person who is sitting nearest to the perigee location, he sees the moon as the supermoon. So this is called the supermoon. When I see the moon in largest position, okay, this is called the supermoon. So from the some place of the earth, I can only view the supermoon. Why? Because there is one place which is basically in front of the perigee location. Not all the places are the perigee. So one place is in the perigee location, another place is in the apogee location. So moon is rotating in this direction. So after some point of time it comes to the apogee location. After some point of time it comes to the perigee location. So once it comes to the perigee location, the person who is sitting closer to the perigee sees the alpha angle. And person who is closer to the apogee location sees the angle beta. So beta is the angle made by the moon on our eye. Alpha is the same angle made by the moon on our eye. But clearly it is observed that the alpha angle is more than the beta angle. That means when I view the moon from the perigee location, then I can see the largest size of it. For the apogee region, I can see the lesser size. So though the actual size of the moon is not being changed, so whatever I am seeing, that is called apparent size. Actual size of the object, actual size of the moon or star is not going to be changed. That is fixed. But whenever I am seeing this, so depending on the angle made by the object on our eye, that size of the image, size of the object is varying. That is called the apparent size. Okay. So let us do one calculation. So let us say initially the object is A1O. Now you move to A2O2. So you are moving this A1O1 object to A2O2. So whenever the object is at A1O1, let us say this angle formed over I is alpha. Okay. This is the angle formed by the object which is placed at A1O1, let us say alpha. Similarly, you move this object, let us say to A2O2 position. At this position, the angle made to our eye, let us say beta. Now clearly it has been observed that beta is more than alpha. Now corresponding to this beta is I2B2. This length is the image. Yeah, this length is the image that is formed on our eye. Corresponding to alpha, the image is I1 V1. This part is the image. Okay. So clearly it has been observed that whenever the angle is increased, that is the image size is increased. Okay. So closer the object, larger its apparent size. So apparent size depends on what? Depends on the size of the image. Okay. Or I can say size of the image also dependent on the alpha and beta angle. So apparent size is dependent on the alpha and beta angle. So if the object is moving closer to our eye, then you can increase this alpha. So optical instruments are doing this. Optical instruments, which are going to be studied later on, are basically used to increase this angle. Let us say there is an object O which is at a distance of 8 from our eye, which is at a distance of, which is height is 8 at a certain distance. So that object is making an angle theta with our eye. Now this same theta is making by the image with our eye also. This is the image part. Okay. So I can see the object which is at a distance, some distance from our theta angle, making a theta, and the same image is also from the angle theta. So this angle is known as theta, visual angle. Okay. So if I change the position of the object, so let us say I am putting this object over here, then the angle theta is increased further. Then this is the angle, let us say theta naught. So theta naught is more than theta because I am moving the object closer to our eye. So moving the object closer to our eye increase the theta, and theta is directly proportional to the image size. So optical instruments are using this artificial technique to improve the clarity of the image by putting the more angle. Now what is the value of theta naught maximum? Now whenever I am saying theta, that is the visual angle that is without any optical instrument. With unaided eye. Unaided eye means without any instrument. Whenever I am observing any object, then object is making an angle theta in our eye. So corresponding to that, what is the value of theta maximum? That is the maximum value of theta. Is the maximum. So from this, what you can say that for that situation, this has to be placed at a distance of capital D. This has to be placed at capital D. So up to capital D distance, I can see the object. So this is the maximum visual angle that can be formed. So theta naught maximum value of theta naught should be equals to h by. Okay, theta naught should be equals to why? Because I am saying tan theta naught equals to h by. Tan theta naught equals to h by. Since this a angle is very small, this theta naught angle is going to be very small. 1 will be 1.5 will be like that. No, not more than that. So since the angle is very less, so I approximately is tan theta as theta naught. So theta naught equals to h by. So this is the maximum value of visual angle that you can produce without any instrument. If the object is visible with that theta naught angle, then it is visible. If it is not, then you have to go for instrument. So instruments are using this technique to increase the theta by some means. So optical instruments are used to increase this angle artificially with some kind of lens. Extra lens, the theta angle can be increased further. Okay. So microscope is one optical instrument which is being used to increase the visual angle formed by the object at the eye. Okay. So it cannot enlarge the object. Whatever the object, that is there. If I see one amoeba or bacteria through that microscope, so it cannot enlarge that object. Object cannot be brought near to it. So these are incorrect options. Only thing what it can do that increase the visual angle. That theta angle can be increased. Theta angle can be increased. So let us say when an observer looks at a distant tree of height 10 meter with a telescope. Now telescope is another kind of instrument. Magnifying power of 20. Now what is that 20 number? Let us say there is a telescope. With that telescope, the person is observing this tree. Okay. Of height 10 meter. So this telescope is, let us say this is telescope. So this is basically the alpha angle seen by the telescope. Seen by the observer, which is at a distance of some distance from the tree. Okay. Now let us say the alpha is very small. So in order to see the tree, he brings the optical instrument known as the telescope. Now once the telescope is there, so the magnifying power is 20. So magnifying for 20 means now it increases this visual angle by 20 times. Now this angle is 20R. This is the concept. Okay. So once it becomes 20 alpha, that means now it will produce a virtual image of this tree at this location. This is the location of the virtual image of the tree, which is basically seen at a distance of 20 times large, 20 times nearer. Okay, 20 times nearer. Why? Because as the object is moving closer to the, so this is the initial object. Okay. Now the instrument is used to increase the visual angle. How much? By 20 times. That means, can I say the object is being closer to this? So this is the eye part. This is the eye part. So closer to our eye by 20 times. Why? Because that is the idea of the any optical instrument. Whether it is a simple microscope, so microscope is there, so it can also increase the visual angle. Okay. Telescope is another type of instrument which is also can increase the visual angle. So every time whenever I am using the optical instrument, the idea is that it will always try to increase the visual. Okay. Yeah. So corresponding with I already said that theta naught, that the maximum value is basically the h by d. Why? Because d is the least distance up to which you can clearly see the object. The maximum visual angle theta naught subtended on our eye when the object is at near. When the object is a near point, then only the theta naught will be maximum. Now, what is that maximum number? That is h by d. And what is h? H is the object size, size of the object, and d is the least distance for the clarification. Okay. Let us say I am observing a tree of 10 meter. A tree of 10 meter height. And let us say a tree of 10 meter. And what that? The theta naught should be how much? Theta naught should be around 10 meter. 10 meter divided by 25 centimeter. That means 10 into 100 by 25. Okay? 25 4 40. Okay. 25 centimeter, 25 by 100 meter. So in the numerator it goes 100. So 40 is the angle. 40 is the angle. So depending on that, the position of the object and maximum visual angle can be calculated. If that is not visible to us, এইটাতে যদি আমরা না দেখতে পাই, that means with that instrument I have to. So for that only, if theta naught is not visible to our eye, that means I have to select an instrument which can further increase it. Further increase this theta. So the requirement of optical instrument. The next we move on to simple microscope. This is the first optical instrument that you should learn. Okay. আমাদের রিকোয়ারমেন্টে কি ছিল? অ্যাঙ্গেলটাকে বাড়াবো। So this angle can be further increased if a converging lens of short focal length is placed. Why short focal length? So if the focal length is on the lower side, then only I can ensure that if the object is, let us say this is the object placed at a distance of u from the lens, and the focal length is, let us say, a. So I want to ensure that a virtual image is formed. Now, in order to produce a virtual image, u must be less than a. Now, in order to produce a virtual image, u must be less than a. So, with this particular microscope, this is simple microscope, or magnifying glass, simple microscope or magnifying glass, you can see an enlarged object, enlarged image. That means you have to place your microscope closer to our object such that the distance should be less than a. Then only the virtual image will be formed. If the object is placed at a distance more than a, then the real image will be formed. So I want to get a virtual image. So for that only, u must be less than a. That means I have to ensure that a short focal length of lens will be used. When a converging lens is used for the increasing the visual angle, it is called a simple. Okay. Now I go for the construction of simple microscope. So if I place an object which is at a distance of less than a, so now the ray will be passing through this lens like this way, and ultimately goes in this direction, converging. And another ray passing through this like this way. So these rays are not meeting, so I have to extend it. I have to extend it backward. So ultimately, here the image is in form of this object. Okay, this is the image part, and that is virtual, enlarged, and along with that is direct image. So that can be produced only when the object is placed less than a distance. Okay, less than a distance. So let us say whenever the object is there, that makes an image, and that image is being observed from our eye. Okay. Can I say when the object is placed at a u equals to f distance, then exactly I can say the image is being found at infinite distance away. Okay. So actual size of the image is infinite, but the angle subtended on the lens and hence on the eye is basically how much? Theta equals to h by a. That is the angle from what I am observing. I am seeing this object. So an object is placed at distance u equals to a from the lens itself. Whose focal length is it? Then the image is being formed at infinite distance away. Image is being formed at infinite distance away. Okay. So this image is also making angle theta on our eye. Object is also making an angle theta on our eye. Okay. So that theta is how much? That theta equals to h by. That theta equals to h by a. So that theta has to be increased. Then only the importance of microscope function becomes. Okay. The visual angle, earlier visual angle was theta naught. So magnifying power, we define the magnifying power of any optical instrument as theta by theta naught. What is theta? Theta is the visual angle produced by the instrument, and theta naught is the visual angle produced by art without instrument. So theta naught is the angle subtended on our naked eye, that is without an instrument, when the object is placed at the near point. Why? Because we know that theta naught is equals to h by d. That is, object has to be placed at near point, then only the theta will be the maximum. And theta is what? Theta is the angle subtended by the final image on the. So final image is being produced where? Final image is being produced at infinite distance. So if the final image is at infinity, so V is infinity. That means that image is also making angle theta with our eye. So I am not going to take the help of that image, but instead of that, I am taking the same angle from the object itself. So for the object triangle, what I can write that theta equals to h by a. Every time I am saying tan theta is equals to h by a. So this is known as the angular magnification. This is known as the angular magnification. Okay. So what is the definition of angular magnification? That is a theta by theta naught. Theta by theta naught. Either you can say this is an angular magnification or it is known as the magnifying power. Okay. That the ratio of theta to theta naught. Theta is the angle. Theta is the angle produced by the image, and theta naught is the angle produced by the object whenever it is placed at the d distance. That ratio. So optical instruments are going to increase this magnifying. That means I want to use one particular instrument or any particular instrument for which m number should be on the higher side. M number should be greater than. Then I can say that instrument is working properly. Okay. Now there are two situations may be possible. One is that the final image is formed on the infinite distance. That means the ciliary muscles are least strained. That means less amount of force is applied on by the ciliary muscles. That means we know that is image at infinity. Image at infinity. So in order to make an image at infinity, you must have to place the object at focal u equals to a. Now for that, can I write theta equals to h by a? Yes. And we already know that theta naught equals to how much? H by d. Theta naught equals to h by d. So corresponding with case 1 situation, whenever what is case 1? Case 1 is known as the normal adjustment. That means you want to make sure that the object is placed at infinity and you are not viewing the object. What you are viewing? You are viewing this image that has been formed at infinite distance. Okay. So whenever you are seeing the far object means object infinity image. So here I am seeing the image, but I am seeing this image. That means for eye, these are basically the object. I am seeing I am not seeing this object. Eye is not observing this object. What eye is seeing the image. So that means for our eye, the image is at infinite distance, so it is relaxed condition. So ciliary muscles are less strained, that is relaxed state. That is known as the normal adjustment. So for normal adjustment, I can write the value of m also. So what is m? M magnifying power is equal to theta by theta naught. Okay, the theta is now h by a, and theta naught is h by d. So ultimately cancel the d by a. Okay, that means a, in order to make sure that m is more than 1, a mass number must be less than d. What is capital D number? You know that capital D is 25 centimeter. That means you have to choose a focal length of a lens which is less than 25 centimeters. Okay. If you use a focal length which is more than 25 centimeters, then the magnification is not there. Okay. You are using the instrument in such a way so that the instrument should magnify the object which is not visible to our eye. Without instrument, I want to see that particular object. So in order to see that particular object, the focal length of the lens must be less than 20 centimeters. If I use the focal length of 5 centimeters, then b by 5, let us say 25 by 5. So magnification is 5. Okay. So angular magnification is 5. That means 5 times increment of that. Theta becomes 5 times theta naught. That is right. Okay. So m equals to d by a for the first situation when the image is in front at infinite distance. So magnifying power is greater than 1. Okay. So in order to ensure that magnifying power is greater than 1, every time your f number should be less than d, that's what we call the small value of focal. It should be on the lower side. It should be on the lower side. So you have to select a particular length, converging length, so that whose focal length must be less than capital D. And now come to the case number 2. So case number 2 is stress condition. That means we want to make sure that your image is in form of the near. Okay. So there are two situations for each of the instrument. One is the case number 1 where we study the image formation at infinite distance away and relaxed state. And thus case number 2 is that image is in form of the near point situation, that is at point D. Okay. So let us say now you place your object at UO distance and you get the image at capital D distance. So for that you want to calculate the theta angle. So here the theta angle is how much? H by U naught. Okay, earlier it was H by A, now it is H by U naught. Now from the lens formula I can calculate the value of U naught also. What is the lens formula? 1 by V minus 1 by U equals to 1 by A. Okay. Now what is V? V is negative. So minus 1 by D. U is also negative. So minus U naught equals to 1 upon F. So it becomes 1 upon F plus 1 upon D should be equals to 1 by U naught. Okay. So U naught becomes how much? F into D by F plus. That is the distance at which you have to place your object so that the image is informed at capital D distance. Okay. So this U naught number is known. Corresponding to this U naught, can I say the value of A theta equals to how much? Theta equals to H by U naught. H divided by FD in the numerator F plus D. That is the theta number. And also you know that for each of the situation, theta naught is same. Theta naught equals to how much? H by capital D. Okay. So ratio of these two will give the value of M now. Now what is M then? M for case 2 should be equal to theta by theta naught. That is equals to H by U naught. And theta naught is H by D. So ultimately we are getting that D by U naught. Okay. Now what is D? D is D. And U naught is, I have calculated that FD divided by F plus D. Okay. So ultimately D cancels out. So we are left with F plus D by A. So that is equals to 1 plus D by D. That is the aim for the second situation. Understood? The aim for the second situation. The magnifying power for the second situation. Second means the near point situation or the stress condition. This is also known as the stress condition or stressed eye. So for the stressed eye condition, the magnification power is 1 plus D by A. In the case 1, it is simply D by A. So if I use a focal length of 5 centimeter, focal length of 5 centimeter, so case 1, for case 1, M should be how much? 25 by 5, that is 5. For case number 2, M should be how much? M should be equals to 1 plus 25 by 5. So it is better. It is better. So case 2 gives more magnification power compared to case 1. Case 2 gives more magnification power compared to case 1. Why? Because there is a one extra one term comes in the picture. 1 is there. Okay. So that is how I can calculate the formula for magnification power or magnifying power for the simple microscope under the case number 2. Okay. So that is the final answer, 1 plus D by. Okay. 1 plus D by. So this is the angular magnification or magnifying power of the simple microscope in the second case. Okay. Understood. Now let us do one situation. So the same situation, the least distance of distinct vision is 25. Magnifying for the simple microscope focal length 5 cm for distinct vision. What is distinct vision? Distinct vision means near point. Hmm. Distinct vision means near point. So near point vision in case number 2. Case number 2. Case number 2, magnification power is how much? 1 plus d by a. That is 1 plus d by a. D is 25 and f is 5. Means 6 centimeter. So 6 will be your answer. Okay. 6 will be your answer. Now, so what you understand that in order to get more amount of magnification power, in order to get more amount, so I want to increase the m number. So for that, only parameter that is f number. Why? Because whether I go for case number 1 or case number 2, answer is either d by f or 1 plus d by f. If I want to increase the f number, so from both of these two cases, I have to reduce the f number. Okay. So if the focal length of the lens chosen to be very small, then only I can ensure that the magnifying power is increased. Okay. So this magnifying power is written with a symbol for unit x. If I use the 10 magnification, 10x, 10x magnification means it is 10 times magnified. 10 times magnified means theta should be at this situation 10 times theta. Okay. 10 times theta. That is the answer. Okay. So if I go for higher number of magnification, then what happens? If I go for higher number of magnification, then you can clearly see that the inner part is seen clearly, but outer edges are somewhat blurred. So these are the blur edges. Okay, that is called the aberrations. Aberration is a kind of defect which will distort the image. Which will distort the image that has been produced. That means I cannot go beyond a certain value of magnification. If due to several other aberrations, the image becomes too defective at the large magnification. If I go for high magnification in the simple microscope instrument, the aberration is more, that means the error is more, that means the defect is more, that means the image quality is less. So magnification power up to 4 times is travelable. Okay. So with this instrument, I can go up to 4 times the magnification, then only I can say that is troublesome. If I go beyond that magnification, then the error inside that or the defect inside that is so much that the image is not clearly visible. Okay.